Sorry about starting so late. Loadshedding ended late for us. Hi, welcome to the Mindwave Vision's winter holiday program. Can you guys hear me properly? Is the video showing? Hi, Colin and Cade. Sorry again for starting so late. Let me do this. Okay. We are starting with fractions today. This is going to be the basics, very basic of fractions, and these rules will apply to algebra and high school students, high school content as well. So take note of, as much as it's just plain basics, it still applies to algebra and all the other topics as well. I know you can't see me. I don't have a face cam. So my name is Abdul Malik. My name is at the bottom of the screen over there. I'll be your tutor for the first part of this week. If you look at the schedule, so all the first topics or first streams for the week, fractions, decimals, and exponents, I will be taking you during those streams. And later on, we have one of our other tutors, Jordan, who will be covering the other streams. And then next week, I'll be doing the grade 11 to 12 content. So that will be the quadratic equations, inequalities, the simultaneous equations, and the exponential equations. We advise, if you are, especially in high school, to try to watch every single stream. It is ordered in such a way that the content for next week is based on this week's content. So you need to know your factorization, you need to know how to simplify expressions, which will help you in later streams. Alright, so let's begin with some fractions. I hope the music is not too loud. If it is, I can try to make it a bit softer as well. Okay. So for fractions, let me make that softer. So with fractions, let's see. So when we have something that is divided, so let's say take a block like this, and we cut it in half, we are creating sections within this block. And this sections is dividing the block. So here we have two parts, and one of these parts we can write like this. So we consider this as a half, and we consider this as a half as well. When we divide this block up into more sections, we're now creating more parts. So there's 1, 2, 3, 4 parts in total. And so one of these parts would be 1/4. In other words, a quarter. When we write it like this, the top part here is the numerator, and the bottom is the denominator. So the denominator will always be the total amount of the fraction, and the top part will indicate how many of those parts is what we need. So for example, if I'm asking you how many of the colored sections of this block, how many sections of this block is colored in, we can see that there's 2 of the 4 sections that are being colored in. The music's okay. So yeah, 2 over 4 would be the amount of colored sections in this block. Now, a fraction can also have a number on the outside, for example 3 and 2 over 5. This is what we call a mixed fraction. Here on the outside this would be a whole number, and this section over here is your fraction. So what that means is, as I said here in the previous part, we have two parts that are colored in of the 4 blocks. But this 3 means that there are 3 blocks as well. So we have 3 whole blocks and 2 of, in this case here, it's 5. So it could be something like that. So that's just what a fraction can look like. Now there are 3 ways that we can write fractions. First one being a proper fraction. And a proper fraction is when the numerator is smaller than the denominator. So in other words, the number on top is smaller than the number at the bottom. So this could be 1 over 9, this could be 2 over 7, 25 over 30. It doesn't matter what the numbers are. The number on top is just smaller than the number at the bottom, and this is a proper fraction. In the opposite, we have an improper fraction. And the improper fraction is the reverse of that, where the numerator is bigger than the denominator. So we can say 30 over 12, or 7 over 2, or 6 over 3. Those are all improper fractions. But an improper fraction we can also write as a mixed fraction. And a mixed fraction is what I just mentioned, where you have the whole number in front and the fraction next to it. So a mixed fraction is 3.5, 5 and a quarter, 25 and 16 over 21, something like that. So that is a mixed fraction, and we can write improper fractions into mixed fractions. So how do we do that? Is if we take this one over here, the 7 over 2, so this is 7 over 2, we can ask ourselves how many times does 2 go into 7? So if we write out the multiples of 2 quickly, so 2, 4, 6, 8, we can see that 7 will lie here between 6 and 7. So how many times does 2 go into 7? 2, 4, 6 can only be the 3 times. So we can write the 3 as the whole number over there. What we then do is we can take our numerator, our 7, and we can subtract the 6 from there. Because the 2 goes into 7 3 times, we can say this is 7 minus 6. And the the denominator will stay the same, which is 2. So this will be 3 as a whole number, and 7 minus 6, which is 1 over 2. So 7 over 2 as an improper fraction can be written as 3.5 as a mixed fraction. And this is important, as some questions do ask you to write your answers as a mixed fraction, and we can also do the reverse of going from a mixed fraction to an improper fraction. So if we take let's say the 5 over 4 over here, so this one over here, so we can also write this as an improper fraction. So what you do is you take your whole number 5 and you multiply it with the denominator, and that answer you will then add to the numerator. So 5 times 4 will give us 20, and we add that to the numerator, which is 1, and again the denominator will stay the same. So 20 plus 1 is equal to 21 over 4. We can do it here with the 3.5. So 3 multiplied by 2 is 6, and we must add that to the numerator, so plus 1, and the denominator stays the same. So 6 plus 1 will be 7 over 2, and we can see that it goes back to the 7 over 2 over there. So improper fractions and mixed fractions, they can be converted between the two. So those are the 3 ways that we can write fractions. In high school, most of the time you're going to be working with improper fractions, just because it's a lot easier to add, to subtract, multiply, and divide as well. So if you are presented with a mixed fraction in high school, do convert it to an improper fraction. It's just a lot easier to work with. Alright, next we're going to look at equivalent fractions. And equivalent fractions is extremely important. Fractions. So equivalent fractions are extremely important, especially in high school, where we need to make the fraction bigger or make the fraction smaller, just so that we can solve for x or whatever the case may be a lot easier. So in simple ways, an equivalent fraction, if we take something like, let's just go with the block again quickly, and we cut it in half. So let's say this block was 30 centimeters or 30 meters. And we cut it in half. That means this is going to be 15, and this is going to be 15 here as well. So 15 plus 15 give us 30. So this one section over here, we can then say this is 15 over 30, and this section obviously is going to be 15 over 30 as well. But remember, I said that they are cutting in half, and in simplest terms, half is 1 over 2. So that means to divide by a half. Oh, sorry, that means to write as a half. But 15 over 30 is also a half because we cut the 30 in the middle, so halfway. So 15 over 30 is the same as 1 over 2. So how is that? So let's take 1 over 2. If we see here that 2, how can we make 2 bigger to 30? We can multiply the 2 by 15. And in fractions, whatever you do at the bottom, you have to do on top as well. So if I'm multiplying the bottom by 15, I can multiply the top by 15 as well. So what we get is that 1 times 15 will give us 15, and 2 times 15 will give us 30. So this is what equivalent fractions are. As much as 15 over 30 looks different to a half, they are equal to each other in that the 15 over 30 can be simplified to a half, or the half can be scaled up to 15 over 30. So by simplifying means to make smaller, so we can take something like let's say 20 over 46. So we can see that they are both they're both even numbers. So you can start by dividing by 2, but you might be dividing by 2 a couple of times. So to make your life easier, what you can do is you can write down the factors. So factors of 20 and factors of 46. Factors just means what times what will give you 20, what times what will give you 46. So let's start with the factors of 20. So the factors of 20 would be 1 times 20, 2 times 10, and 4 times 5. And then the factors of 46, let's just move this here. So it will be 1 times 46, and then 2 times 23. Can 3 go in there? No. 4 can't go in there. 5 can't go in there. 6, no. Is that it? I think that is it. So those are the factors of 46. And now we look for the highest common factor. So the highest common factor is the number that appears in both sets, or the highest number that appears in both of these sets. We can see 1 appears in both, 2 appears in both, and that is it. So that means 2 is the highest common factor. So what we can then do is divide by 2, divide by 2. So this will be 20 divided by 2, which gives us 10, and 46 divided by 2 will give us 23. So 20 over 46 is exactly the same as 10 over 23. They are equivalent fractions. And we'll do some more of the equivalent fractions when we get into the calculations. So yeah, that is equivalent fraction. So we can scale up, so to multiply. Okay, we can multiply by 15 to increase the half, or we can make smaller by dividing by 2. So that is what the equivalent fractions are. We can make bigger, we can make smaller, and we just do that using multiplication and division. Alright, so now let's get into some of the calculations for fractions. So let's look at adding fractions. So when it comes to adding fractions, there are 2 things that we need to take note of, and that the first one being, in both cases it's going to be the denominator. In the first case it is where the denominator is exactly the same, and the second case is where the denominators are different. So if I have something like 1 over 4 plus 2 over 4, we can see here that the denominators are the same. So when we're adding fractions, we want the denominators to be the same. So the denominators are the same, and we can keep the denominator. So now we just add the numerators, we just add the top parts. So this is 1 plus 2, and 1 plus 2 which just can give us 3. And it doesn't matter what the numerators are, as long as the denominators are the same, we can add fractions. So this could be 100 over 25 plus 6 over 25. Because the denominators are the same, we can still add the numerators, which is 100 plus 6, which is 106 over 25. And just because the numerator is over the just because the numerator is bigger than the denominator, we can write this as a mixed fraction if we'd like. So we can say how many times does 25 go into 106. So we can write down the multiples of 25. It's going to be 25, 50, 75, 100, 125. Okay, we don't have to go further than that because we can see that the 106 is over here. So what numbers are before that? It's 25, 50, 75, and 100. That means that 25 goes into 100. So sorry, 25 goes to 106 4 times. 1, 2, 3, 4. And there's going to be a remainder of, we can say 106 minus this 100 over here. And again, denominator will stay the same. So 106 minus 100 will give us 6, and the denominator of 25. So that's the first case of adding fractions. When the denominators are the same, we just add the numerators. But what happens when the denominators are not the same? So let's say 3 over 4 plus 5 over 7. So we want to make the denominators the same. And we can do that using equivalent fractions. So what we do is you want to write down the multiples of 4 and the multiples of 7. So 4, 8, 12, 16, 20, 24, 28, 32. And then the 7, 7, 14, 21, 28, 35, sorry. 42, 49. You don't have to go so far. We can already see that 28 over there is the highest, or sorry, the first multiple that appears in both. So 28 is going to be our what we call the lowest common multiple, or the lowest common denominator, or your LCD. So our LCD is 28. So now what we want to do is we want to scale up, or we want to increase the 4 and increase the 7 to equal to 28. So what do I need to multiply by 4 to give us 28? Well, you just count down your list. So 1, 2, 3, 4, 5, 6, 7. So we need to multiply by 7. And what we do at the bottom, we have to do on top as well. And the same thing for the 7. What do I need to multiply with the 7 to give us 28? We just count 1, 2, 3, 4. So that's going to be 7 times 4. What do we do at the bottom? We will do on top. So starting with the denominators, 4 times 7 will give us 28. 7 times 4 will give us 28. So now we just multiply the numerators. So 3 times 7 is 21. And 5 times 4 is 20. The denominators are the same, so I can keep the denominator and add our numerators. And 21 plus 20 gives us 41 over 28. Again, we can write this as a mixed fraction. This is going to be 1 and 41 minus 28 over 28. So 41 minus 28 is going to give us 13 over 28. So it doesn't matter when if the denominators are different, we just need to get them to be the same, and then we can add our fractions. Now there is an easier method when it comes to having two fractions. So let's do something like 5 over 6 plus 1 over 4. We can write the multiples out. Our 6 multiples of 4, and we get our LCD. But there is something else that we can use, which is called the butterfly method. Oh, my handwriting's bad. So the butterfly method is where we take the denominators and we multiply them, and then we take the 5 and the 4, let me change colors. We can then take the 5 and the 4 and we multiply, and we take the 6 and the 1 and we multiply. So let's take this step by step. So we start off with the denominators that we need to multiply. So 6 times 24, 6 times 4 is 24. And that's going to be our denominator. What we then do is we take this numerator and we multiply it with the second fraction's denominator. So this is going to be 5 multiplied by 4. And then we put our plus sign down, and then we can do the other side. We take the numerator of this second fraction and we multiply it with the denominator of the first fraction. So that's going to be 6 multiplied by 1. So if you remember BODMAS, we have to multiply before we can add. So 5 times 4 is 20. Add 6 times 1 is 6. That's going to be over 24. So 20 plus 6 is 26 over 24. So we can do that method as well, which is the butterfly method. So I'll go over it again using another example. Actually, let's just use this same example over here, and let's see if we get to the same answer. So 3 over 4 and 5 over 7. 3 over 4 plus 5 over 7. So we start with multiplying our denominators. So 4 times 7 is 28. And then we multiply those two. So that's going to be 3 multiplied by 7. And we add the product of these two. So we multiply the 5 and the 4. So 3 times 7 will give us 21, plus 5 times 4 will give us 20 over 28. And this will equal to 21 plus 20, which is 41 over 28. And we can see that it is, it's exactly the same answer over here. 41 over 28, and we can obviously change to a mixed fraction. So you can use writing out the multiples to give us equivalent fractions, or you can use the butterfly method. Just again, I'll write this out for you. It's multiply denominators. So you start off with this first part of here. Second, you then take numerator of first fraction, and that will get multiplied by the denominator of the second fraction. And then the third one is going to be numerator. I'm just going to write num. So you're going to go for the numerator of the second fraction. And that's going to get multiplied by the denominator of the first fraction. Right, so just using the example here that's on the left, the first step is the yellow, the second step is the blue, and the third step is the green. Step 4, you just add the numerators. And that is the butterfly method. Now, what happens if you have more than 2 fractions? So something like, oh wait, if you are writing this down, I'll leave that up for you for a second. If you do have more than oh, there's 8 missing. If you do have more than 2 fractions, so I'm just going to use simple numbers quickly. So half plus a third plus a quarter. If this is the case, that you are working with more than 2 fractions, it is best that you go with the writing out the multiples. So now I can find the LCD of all 3 fractions at the same time. You can, if you want to, if you just want to add those 2 first, you can do that and then add it with a quarter, although that's going to be a bit longer. So I would suggest you write down the multiples of 2, so it's going to be 2, 4, 6, 8, 10. Multiples of 3 is 3, 6, 9, 12, 15. And the multiples of 4, which is 4, 8, 12, 16, 20. And now we just find the LCD. So what's the number that appears in all 3 lists? So you can see there's a 6 and 6 over here, but there's no 6 in the 3rd list. There's an 8 and an 8 over here in the 1st and the 3rd row column, sorry, but there's nothing in here. We can see that there's a 12 and a 12 over here, and if we do extend the list of the first one, then 12 does appear in all 3 lists. So 12 would then be our LCD. So that's going to be the denominator for all three fractions. And now we just use equivalent fractions. So it's going to be 2 times what? So we just count down how many we go. You can't see the red? Oh, okay. Do you want to write it down? You don't have to write it down. I'll make the red a bit bigger. Is this for term 3? I'm not sure. Some schools did fractions. I know they did fractions in term 2. But if this is for term 3, well, then you're going to be ahead of your class. Where was I? Oh, yeah. So we just use equivalent fractions to answer this now. So we count down the list. So 1, 2, 3, 4, 5, 6 until we get to 12. So you multiply that by 6, and we do it on top as well. For 3, we go 1, 2, 3, 4. So you just multiply by 4 over there, and what you do at the bottom, you will do on top. And then for 4, it will be 1, 2, 3. So we're going to multiply that by 3, and what you do at the bottom, you will do on top. So the denominators, we know they're going to equal to 12 because it's our lowest common denominator. So we just have to work with the numerators now. So 1 times 6 is 6, 1 times 4 is 4, and 1 times 3 is 3. And since our denominators are the same, we just have to add the numerators. So 6 plus 4 plus 3. 6 plus 4 is 10, 10 plus 3 is 13. And once again, we can change this to a mixed fraction. We can see 12 is very close to 13, so we know it's only going to go in once. So that's going to be 13 minus 12 over the denominator of 12. So 13 minus 12 is 1 over 12. So there we go. That is adding fractions. So what about subtracting fractions? Well, it's exactly the same. Nothing changes except the plus will change to a minus. You just have to subtract. But the method is exactly the same. Find lowest common denominator by writing out the multiples. If you want to use the butterfly method, you can use the butterfly method. But instead of using a plus, you're going to be using a minus. If you have multiple fractions that you need to subtract, then you do it exactly the same way. So if I were to change using this over here, if I change this last one to a, where's my mouse? There we go. So if we change this last one here to a minus, then this will change to a minus here as well. And then this will change to a minus. So instead of it being 13, we can then say 6 plus 4 is 10, minus 3 is 7. Then this doesn't apply over here. So adding fractions and subtracting fractions are exactly the same thing. Oh, sorry, they're exactly the same method. Right. Oh yeah, there's something else that I wanted to show. If there are high school students that are watching, just because algebra is being added, letters are being added, it doesn't mean that it's going to be any different. So if we have something like, let's say 2 over x plus, and I know this is very, very simple, but if you have 2 over x plus 5 over x, the denominators are the same, so you keep it as x, and we can still add the numerators, 2 plus 5, which is 7. Or if you have something like 5 over x plus 7 over y, again we use the butterfly method. So we multiply the denominators, x and y will give us xy, and then we say 5 multiplied by y, and then 7 multiplied by x. So this will give us 5y plus 7x over xy. You will do more of this in algebraic fractions. Let me see, when is algebraic fractions happening? So next week, Monday, you'll be doing algebraic fractions. You'll go more into depth with this. But I just wanted to show you that even though x and y and whatever letters are added, the exact same method and still applies. So that's why even though I'm just using numbers over here, the method still applies in algebra. Alright. Let me just check something quickly. Now, one of the key things about fractions, or what can make fractions difficult, is when the numbers get a lot bigger. So when we work with something like 125 over 250 plus 75 over 50, for example. So when numbers start getting bigger, that's when kids start to freak out. But one thing you need to keep in mind is that we can try to simplify before we even add. So early on when we did equivalent fractions, or we've been doing equivalent fractions, if you look at these over here, we've been making the numbers bigger. So by multiplying, we can make the fractions look bigger. So by making the numbers bigger. But we can take big numbers and make them smaller. So we can try to simplify these fractions before we add them. Because we don't want to say 250 multiplied by 50 to get our LCD, because that's going to be a big number. So what you want to do is try to simplify each fraction first, and then we can try to find an LCD. So 125 and 125 and 250. If we look at the multiples of 125, so usually when you are, this obviously for the grade 7s, if you are working with these big numbers, they're not going to make the numerator and denominator far apart. What I mean by that is, if we take the multiples of 125 and the next number is going to be 250, you can see that they are very close to each other in terms of multiples. So 125, 250, 375, and then 500. Yeah, so the numbers, if they are big, they are going to be close to each other in terms of multiples. So we can see that 250 and 125, they are multiples. So what we can do is we can say 125 can divide into 250, so we can divide by 125, and what we do at the bottom we can do on top. So 125 divided by 125 is 1. Anything divided by itself is going to equal to 1. And 250 divided by 125, or we can count here on the right side, that's going to be 2. So there we go. So 125 over 250 is just half. So what about 75 and 50? So if you want to write down the multiples of 50, so next number is 100, we can already see we're passing 75. So that means 50 and 75 are not multiples of one another. Same thing with 75, the next one is going to be 150. So what we then want to do is we want to write down the factors for these two numbers. So what times what will give you 75 and what times what will give you 50. Factors of 75. So it's going to be 1 times 75, 2 can't go in there, 3 times 25, 4 can't go in there, 5 times 15, and I think that is it. For the factors of 50, it's going to be 1 times 50, 2 times 25, and 5 times 10. So what is the highest common factor that appears in both sets? 1 is there, 5 is there, and there's a 25 in both of them as well. So 25 is going to be our highest common factor, so we just divide by 25 over here. So 75 divided by 25. So we can just look at the number that's next to it. So that's why I write the factors like this. I write them in pairs. So what times what will give you the 75, or what times what will give you the 50. Because now when we divide 75 by 25, the answer is 3. So the answer will just be next to the number, next to your highest common factor. So 50 divided by 25 is 2. And we can write our answer over there. So we can see over here that by simplifying our two fractions, we actually get the same denominator. So now we just add, which is 1 plus 3, and that's going to give us 4 over 2. And 4 is a multiple of 2. 2 goes into 4 twice. So it is best that you simplify your fractions first. Simplify means to make simple, and when it's simple, it's a lot easier to work with. So try to simplify your fractions first, and then you can try to add or subtract them. What did I want to say? I just lost my train of thought. But nonetheless, simplify, simplify, simplify before you start adding or subtracting, and then simplify at the end as well. It's just to make things a lot easier for yourself. Alright, we still have a few minutes left. Let me just check how much time we have left. Alright, about 15 to 20 minutes. Alright, let's move on then to multiplication. Multiplication of fractions is quite easy. If we have a fraction multiplied by 13, for example, then all you have to do is multiply the numerator by the numerator, multiply the denominator by the denominator. So you're going to be multiplying across like that. So it's going to be 3 times 6 over 5 times 13. 3 times 6 is 18, and 5 times 13 is 60, yeah, 65. And there we go. That's it for multiplication of fractions. Same thing over here though. If you have, let's say, 5 over 15 multiplied by, I'm going to use the same one as before, 125 over 250. Again, simplify. So write down your multiples of 5, sorry, write down the factors of 5, write down the factors of 15, and you'll find that 5 is the highest common factor. And we did this one earlier, which is 125. So simplify this further, because obviously you don't want to say 15 times 250. So simplify. So 5 divided by 5 is 1, and 15 divided by 5 is 3. 125 divided by 125 is 1. 250 divided by 125 is 2. So now it's a lot easier to multiply. 1 times 1 is 1, and 3 times 2 is 6. When we're multiplying fractions, we can also simplify in a cross method. So what do I mean by that? If we have something like 4 over 9 multiplied by 6 over 16, or let me say, yeah, that's fine, 6 over 16. We can also simplify in a cross pattern. So what we can do is, just a second. We can simplify in a cross method. So we can see 6 and 9. So if we write down the factors of 6, it's going to be 1 times 6 and 2 times 3. And then the factors of 9, which is 1 times 9 and 3 times 3. You can see that the highest common factor is going to be 3. So you can divide by 3 here and divide by 3 over here. This can only happen in multiplication, not in addition or subtraction, only in multiplication, where we can divide in a cross pattern. Same with 4 and 16. We know 16 is 4 times 4, so we can divide this by 4, and we can divide this one here by 4 as well. So 4 divided by 4 is 1, 9 divided by 3 is 3, 6 divided by 3 is 2, and 16 divided by 4 is 4. And then we can see that we can still simplify the second fraction over here, 2 over 4. We know 4 is a multiple of 2, so we can divide by 2 on top and at the bottom. So keep the first fraction as is. 2 divided by 2 is 1, 4 divided by 2 is 2, and now we just multiply. 1 times 1 is 1, and 3 times 2 is 6. I hope I didn't go too fast. But that is simplification. So we can simplify within a fraction, within one fraction, top and bottom. But we can also simplify in a cross method. So the numerator of the one fraction with the denominator of the second fraction, numerator of the one fraction, denominator of the second fraction. Only with multiplication of fractions can this happen. If you are working with multiple fractions, so something like that, 1 over 3 times 1 over 2 times 1 over 4 times 1 over 6, they still all get multiplied the exact same way. So numerators get multiplied, denominators will get multiplied. So in this case, 1 times 1 times 1 times 1, so just multiplying the 4 numerators, and then 3 times 2 times 4 times 6. When you're multiplying by 1, it will always stay the same. So 1 times 1 will be 1, 3 times 1 will be 1, 3 times 1 will be 3. So just multiplying by 1 will keep the number exactly the same. And then at the bottom, we can multiply this out. This is 3 times 2, which is 6 times 6 is 24, and 24 times 4 is 96, I think. Let me just double check that. So 3 times 2 times 4 times 6, no, it's 144. So multiplication, very straightforward. And yes, if you are high school students, this applies to algebra as well. So x over y multiplied by y over x will be x times y, which is xy, and y times x, which is xy as well, which gives us 1. I'm not going to go into depth with that. Do watch the other streams for more information about that. But I just wanted to show you once again that the methods that we use for simple fractions, they do apply to algebraic fractions as well. And then lastly, division. When we're dividing fractions, so let's say 1 over 3 divided by 5 over 3 as an example. When we're dividing fractions, you want to not use division. We use a method, let's call it tip and times. Tip and times is to tip the second fraction and to change your division to multiplication. So you'll keep your first fraction, the division will change to multiplication, and you will tip the second fraction. Tip meaning to write the top at the bottom and to write the bottom on top. So your denominator 3 over here will now become the numerator, and the numerator 5 will become the denominator. And now we have multiplication. And now you just go back to the multiplication methods. We can see that there's a 3 in the numerator and a 3 in the denominator. So what they can cancel. Whenever two numbers are exactly the same, one on top and one at the bottom, they are able to cancel. And when they cancel, you're left with a 1 over there. So 1 times 1 is 1, and 1 times 5 is 5. Else, if you didn't see that, what you could have done was just go straight to multiplication, which is, let me just write this out again. So 1 times 3 is 3, and 3 times 5 is 15, and then simplify here. 15 is a multiple of 3, so we can divide by 3 over here, and what you do at the bottom you must do on top. Alright, and 3 divided by 3 is going to equal to 1, and 15 divided by 3 is 5. So there we go. That's division of fractions. It's just to change your division to multiplication, and the second fraction will change. So if you are in a, let's say, a Bodmer's type question, we have something like 1 over 3 plus 1 over 5 divided by 2 over 5, for example. Since division comes before addition, we have to focus on the section first. So you do want to change the division to multiplication, and then tip your second fraction and proceed to continue with BODMAS. Obviously multiplication first, and then we do addition. We'll go more into BODMAS later on in the week. And that's going to be most of fractions. Yeah, that's going to be most of fractions for us. Tomorrow we'll go into more bigger numbers. We're going to bigger numbers, as well as we might bring decimals and percentages. We're going to start with that tomorrow instead of Wednesday, and we'll do the conversions between those three as well. But that's going to be it for today. In an hour's time, we are going to start with Introduction to Algebra. So if you are in high school, you can move to the next stream and wait for Jordan, which is our other tutor, to start with Algebra. So if you are not in the next stream, I will see you then tomorrow at 12. Hopefully there's no load shedding, but if there is, just do wait in the stream. We can obviously just wait till load shedding is done. But nonetheless, I hope you guys have a wonderful day, and I will see you tomorrow. Take care.